What's up guys, welcome back to the channel. Jaime Garcia from Intuitive Fabrication, and today we are making a small welding positioner. So I had this chuck that I purchased a while ago from someone that was nearby, local. I got it for like 40 bucks, which is a cool little price. It's a three prong chuck, and I've already made a base plate for it. So this base plate I designed and cut out on the CNC plasma, and then I've already ordered some solid rod, machine rod, to fit into here, and that way we can fit these bearings here into this top plate. This is going to be the top plate for it. Cut out little sections so we can meet up all the plates together, and this bearing essentially is going to sit into this plate like this, and that'll be where this shaft goes through. So we'll go ahead and weld this up, and then we'll cut out the other plates and see how it looks. Alright, so check this out. This is where we're at with it. I went and cut out these bottom plates you already saw, so I went and cut out the side plates, and this has a 5/8 bearing in it, so that way we can rotate the positioner from a 90-degree angle to a horizontal to a vertical angle essentially. So this is going to slide through here. It'll rotate on this, on the outer casing. I still have yet to do that. That's what's next. But I want to make sure all this worked, and it looks like it does. So this spins freely here. It's all lined up. And then this is going to be the shaft that the motor is going to rotate on. And this rod is in here. The bearing is locked in. You can see that the chuck is here, and it spins beautifully. So the motor that I have is a very small motor. I didn't think it was going to be this small when I got it. I also got this matching sprocket here to match up with that one, and it essentially turns on a small belt, which is here. So this belt will go on here, and it'll spin on the other side. This is what is it? It's a 10 RPM motor. I know some of the Vibor ones came with 20 RPMs, and there's a lot of complaints about it just not moving slow enough to really weld with, and it going faster than what you would ever need it for as far as welding goes. So I'm hoping this works out. It says that this motor pushes 15 kilograms, and so the chuck that we have here is 16 pounds, and I'm hoping that the bearings help with this a lot. So I got to find a spot to fit this up at. I went and got the hardware for it, so I'll probably fit it up somewhere over here and mount it and see if I can make it a little adjustable so we can put tension on that belt, so that way it's not skipping around. So we'll work on that next. Alright, so as far as that little motor that I showed you guys, a little fun size motor that I got, I needed something to mount it up with. So I was gonna use initially these top bolts to make a bracket to mount it, but I didn't really like it, and I don't know if my plasma cutter can cut holes this small very accurately. So I basically came up with this. This is going to be welded onto the side plate, and this motor is going to slip in, and this allows for adjustment up and down. And then I put in a set screw here so that I can tighten it, and that'll lock it in place. And then depending on how much tension I want, as you can see when I rotate it, I can change the tension on the belt. So I think this worked out pretty cool. I'm gonna go ahead and weld it onto the side plate, and then I'll show you guys what that looks like. So I got this all welded up on here, and as you can see, I aligned it, and then I put some tension on it, so now the motor is locked into place. And the next thing I'm gonna do, aside from the outside frame where this thing is gonna spin on, and I can adjust it from 0 to 90 with these holes, with the 10 pins, I have to wire all this stuff up. And I already tried this out when I tested the motor just to see kind of what it was like. I've had this thing in my garage for like 3 or 4 years or something like that. And I've always had the plans to do this, I just never got around to it. Really lacking motivation. But I tested it out the other day. This thing here is to convert the output from the wall outlet at 110 to 12 volt, because this motor operates off a 12 volt, and so does this dial. And then I picked up this small foot pedal, which I don't know if I like it, but we're gonna give it a shot. It does work. It takes a second. Once you hit it, it takes a second. And I'm gonna go ahead and reuse one of these plugs. This basically uses a plug that plugs into the wall, and then the other side, I'm gonna have to cut or order a plug that fits into here and has a flying lead. That way I could connect it to this side of the converter. This is what I used the other day to test it, were just these pins. And I just stuck them in there to make sure everything worked before I got going. So it works pretty good. So I'm gonna go ahead and try to find a spot for these, and I'll show you guys where that ends up at. So I got these side plates made already. I cut them out. This is going to be the base of the stand. And then these support plates down here. Looks pretty good. I already found out where I messed up. I was going to have this pivot, but obviously my pivot point is up here, so these don't line up when I put it vertically. So I'm going to have to take care of that once I get everything put together. I'll bring it to a vertical position, and I'll see where the hole's at. I want to drill a couple holes here anyways, just so I could have a little more adjustment. So I'll work that out once everything is put together, but right now I'm gonna tack these together for you guys. Alright, so this is going to be it for today. I'm going to go ahead and hook up the electronics later. I went ahead and welded all these corners in. But tomorrow we'll hook up everything, and then hopefully I'll be able to show you guys what this thing does, if it works. So I'll be back tomorrow. Guys, so it's a new day, and I have this kind of set up how I want to, wired in the motor. I'll show you guys how it rotates in this next clip here, but I still have to cut this down short, and I still have to make pins for this, but it functions how it needs to, and I'll go ahead and show you guys a video of that right now. So you can see, this is about as fast as it goes here. That's turned all the way up, which is a pretty decent speed, and then we can turn it down pretty significantly. That's pretty slow right there. I don't know if you guys can see it on camera. I can turn it down even lower, where it's barely just crawling. So I think this motor was a good a good option for this because it goes as slow as I need it to. And then if I wanted to pick it up for whatever reason, which I don't see myself welding at that speed, I can do that also. That's it. So this is just a couple of test runs. I got to get the speed down with the settings right, but this is kind of what it's doing. A little high, so we're gonna have to go up on the heat or go down on the speed, which I can. But it looks like just getting this thing dialed in, it works exactly how it's supposed to. So thank you guys for joining me for this. This thing's gonna come in handy whenever we got to do round tube or anything like that, or if I have to TIG weld some custom intercooler piping or exhaust pieces, things like that. So thank you guys for joining me again. I'm glad that this worked out. So I'll show you guys videos of it once I get something to weld on it. Subscribe, share, appreciate it.